All right, welcome back. Today, we're jumping into a real clash of the titans in the Python data world. We've got the long-reigning champion, pandas, going head-to-head with the super-fast challenger, polars. So let's get right into it.
So here's what we're going to cover. First, we'll set up the core problem, the DataFrame dilemma. Then we'll dive into how these two tools actually think differently. After that, we'll talk speed, syntax, and then, the big one, how to choose the right tool for your job. And stick around, because we'll also see how they can actually work together.
Okay, let's set the stage. In one corner, you've got pandas. It's the industry standard, right? It's the tool that pretty much every single one of us learned first. And in the other corner, you have polars, a much newer library that was built from the ground up for one reason and one reason only: pure, unadulterated performance.
I mean, let's be real for a second. We have all been there. You kick off a command on a big data set, and then you just sit there, staring at the screen, waiting. That feeling, that massive bottleneck, that's exactly why this whole conversation is so incredibly important right now.
Now, before we get any deeper, let's just make sure we're all on the same page. When we talk about a data frame, all you need to picture is a table. Seriously, it's like a spreadsheet living inside your code. It's got rows, it's got columns, and it is the fundamental thing we're working with in both pandas and polars.
So here's the best way to think about this. An analogy we're going to keep coming back to. Think of pandas as your trusty Swiss Army knife. It's super versatile, it's got a tool for almost everything, and it's great for a ton of different jobs. Polars, on the other hand, well, polars is a power drill. It is highly specialized, incredibly powerful, and it does its one main job, high-performance data work, better than anything else.
Okay, so to really get why these tools are so different when it comes to speed, we have to pop the hood and look at how they're actually built. This is where the magic, or the engineering, I guess, really happens.
And here it is, the single most important difference: how they store data. Pandas is row-based. So imagine a filing cabinet where each folder contains a complete file on one person. Name, age, department, everything. It's great if you need to pull that entire file at once. Polars is columnar. This is like having separate lists for all the names, then another list for all the ages, and a third for all the departments. If you only need to calculate the average age, you just grab that one ages list. It's way more efficient for analytics.
Now, this brings us to what is basically Polar's superpower, something called lazy execution. See, instead of running each command the second you type it, which is what Pandas does, Polars just waits. It collects all the steps you want to take, figures out the absolute fastest way to get to the final answer, and only then does it execute that one super optimized plan. It's a total game changer.
So we've talked theory, we've talked architecture. But what does this all mean for what we really care about: speed? Let's see how this stuff actually plays out when you've got a massive data set and a deadline.
And yeah, the difference is just, well, look at it. It's huge. For a really common task like a group by on a big data set, we're not talking about a small improvement. It is a dramatic leap. Polars can be orders of magnitude faster. It turns what used to be a go-get-coffee operation into something that's done in just a couple of seconds.
So how does polars pull off this magic trick? Well, it's really a combination of three key things. First, it uses all of your computer's CPU cores right out of the box, no extra work needed. Second, that columnar model we just talked about means it never wastes time reading data it doesn't need. And third, that lazy execution engine puts it all together and optimizes your whole workflow before it even starts. Okay, so it's fast. We get it. But is it a pain to write? What's the code actually look like? And how does it fit in with all the other tools we use? Let's talk about the practical, day-to-day stuff.
Let's look at a simple filter. At first glance, they look pretty similar, right? The Pandas code feels a lot like slicing a list. But the Polars code is a bit different. It's more declarative. You're not telling it how to get the data, you're just describing what you want, using an expression. It's a subtle but powerful shift in thinking.
And we see that same pattern here with a more complex task. In Polars, you're very clearly building a pipeline of expressions. You're saying group by this column, and then aggregate by taking the sum of that column. It makes the logic incredibly clean and easy to follow, especially as your transformations get more complicated. And that really gets to the heart of the matter. Honestly, learning Polars isn't about memorizing a bunch of new commands. It's about shifting your mindset. You're moving away from a step-by-step, do this, then do that approach, and into a more declarative, here is the recipe for the final thing I want approach.
So after all that, we land on the most important question. Which tool should you be using? When is it the right call to stick with pandas, and when should you reach for polars?
let's get really practical. You're going to want to stick with your Swiss Army knife, pandas, when you're doing that quick, interactive, exploratory work, especially in a Jupyter notebook. It's absolutely perfect for smaller data sets that fit easily in memory, and, crucially, its integration with the machine learning world like scikit-learn is still second to none. It's all about flexibility.
But you'll want to grab that power drill, polars, anytime performance is the top priority. We're talking about production data pipelines, massive data sets that are pushing the limits of your machine's memory, or any situation where speed is absolutely critical. And if your world involves giant Parquet files, trust me, polars is about to become your new best friend.
But here's the really cool part. It's not always an either-or choice. You don't have to throw away all your pandas code. In fact, one of the smartest strategies is to use them together.
There's a brilliant, low-risk way to do this called the strangler pattern. Here's how it works. You find the one single slowest part of your existing pandas code. You rewrite just that tiny piece in polars to get that huge speed boost. Then, you simply convert the result back into a pandas data frame, and the rest of your pipeline just keeps going like nothing happened. You get a massive performance win without having to rewrite everything. It's brilliant.
So look, at the end of the day, this whole thing isn't about declaring a winner in a pandas versus polars fight. There is no single winner. The real goal here is to arm you with a mental model so that you can look at any data task and know with confidence exactly which tool is the right one for that specific job.
And so that brings me to a final question for you. Now that you know the difference, now that you can spot the bottlenecks, and you know there's a power tool waiting for you, what's the first slow, frustrating part of your own workflow that you're going to go and optimize? Think about it. Thanks so much for watching.